So here's the thing about AI right now. If you've looked into only the headlines, you might believe that GPUs and AI accelerators were the entire story. They dominate the conversation, they drive stock markets, and they are the reason entire data centers are being reimagined. They deserve that spotlight. They're incredibly powerful at the heavy math that sits at the center of modern AI models, and they have enabled the progress that everyone is talking about. What does not get much attention is the fact that even the largest and most advanced hardware still spends too much time waiting, sometimes up to 70 to 80%. They're waiting on a lot of different things, most noticeably data in the right format. The reason why it waits is two parts: where the data is and how the data is orchestrated. On one side you need fast memory, and on the other you need a really good CPU orchestrating that data plane. In a server, CPUs remain essential. They are versatile, flexible, and at the core of almost every computing task you can name. If you need to run an operating system, schedule workloads, or manage complex general-purpose jobs, the CPU is unmatched. The AI inference has evolved into a workload with very different demands. It's a messy mix of token preparation, data shuffling, networking, and orchestration. A regular CPU can handle those jobs, but there's a trade-off in flexibility compared to optimization. They were never optimized for the pace required by large-scale AI inference. And that mismatch creates an odd situation. A data center may invest millions in racks of accelerators, but much of that investment is left underused because the hardware is left waiting and the hosts are busy doing management tasks. It's like hiring the best chef in the world, but then asking them also to seat customers, clean dishes, and manage behind the till. The chef is still brilliant, but the kitchen never runs at full speed. On the other side of this, the flip side of this, is the networking, with most companies focusing on speed above all else. Get the data to where the compute needs to go. That's why InfiniBand and Ethernet exist. There are two ways to approach this: dumb networking, which just moves the data, or smart networking, which helps compute the data. Solutions for the latter are complex and often problem dependent. Between the two, it all means that the industry's main response so far has been to keep scaling the GPU and pushing the software to ever more parallelism. Every new generation arrives larger, faster, and more capable. That progress is real, but it does not fix the imbalance. The CPU is still managing orchestration, still tied to jobs that it was never its specialty. And as the network is shuttling that dumb data around, the accelerators are still waiting. This has led some to ask whether there should be a set of chips designed specifically for those orchestration tasks. A dedicated chip that takes on the data preparation, the networking, and the flow control in order to let accelerators flourish. CPUs will continue to do what they do best, and GPUs will keep pushing the boundaries of the mathematics. But inference at scale might benefit from a processor whose entire role is managing the pipeline around the workload. Now that is the idea behind the AI CPU, and it is the concept that a company we've been speaking to has been developing. Their chip, called the NR1, was built from the ground up to serve inference. The goal is to let the accelerators run flat out on the mathematics while this new processor handles the entire orchestration around them. It's similar to adding a conductor to an orchestra. The musicians are already talented, the instruments already world-class, but without coordination, you'll never hear the full performance. In an orchestra, it's one-to-many. The modern inference workload requires one conductor per chip, and we've seen some demonstrations with 8 of these NR1 chips paired with 8 Qualcomm AI Ultra cards. Now, to dig into this, we met up with Moshe Tanach, the CEO and co-founder of NeuReality, at a recent conference. I initially went into this interview expecting to talk to him about the NR1, but as the conference started, the company announced their new AI Super Network product, something that we weren't expecting. For context here, Moshe spent years at Intel and Mellanox, and a lot of the team at NeuReality heralds from big networking players. We asked him to walk through the NeuReality concept and why they see a growing market for their hardware. Cue the clip.
I think when we founded the company, we were looking on the data center as something that is going to transform. GPUs are becoming stronger and stronger. XPUs that do better job in some cases, and they need a lot of data. They need a lot of data because they are very powerful. They can run a lot of request processing, but also because when we reach larger problems like huge LLM, DeepSeek, ChatGPT, and the alike, while you train or while you run inference, there's a lot of east-west communication between those GPUs. So The first thing we went after is, if you look on the server, it has the CPU and the front-end NIC defined as the head node that manage the server node. Then you have the GPUs that are doing most of the processing. And then you have the scale-out NICs. So we went after the AI head node, and we kind of fused the two functions together.
I remember the first time we met, it must have been something like Supercomputing 2022. And you had some of the demo systems, and I said, "Where's your CPU?" Because
I remember that.
you were partnered with, I think, AMD and Qualcomm and IBM at the time, showing off some things, and you were saying, "You don't need one, because we got this thing that does it for you."
Exactly. Well, actually, we have embedded CPUs. The first generation had the Neoverse N1 from ARM running. You have to give the same look and feel for the developers and for the IT guys. So we have ARM server on a chip.
Yeah.
But more
So you're an ARM merchant silicon provider.
I am.
Ah.
I am.
One of the successful ones, apparently.
Yeah. So the first problem we went after is, how do you couple the GPU with something that can bring data very efficiently, as you mentioned, but also process it and prepare it for the GPU? Many times when you enable multiple engines inside the GPU, they interfere with each other. You enable the video decoder, your neural net processing drops. So we built this AI head node that does the data fetch, data processing. It can reach the storage. It can get data from clients. And just in the last few days, we announced the second generation that address the east-west problem for large training pods. Hyperscalers need it. Other big semiconductor that doesn't have networking need it. So it's a very important thing. And I can share with you some of the research we've done with DeepSeek on, they released their article about how they trained and how they did this load balancing that you mentioned.
Yeah.
And they
had to be smart with the networking.
Very smart, very smart. And with splitting the work and doing it on a tile basis. How do you transform some of the data while you compute so you don't lose GPU active time? And they've done amazing work. But the only reason they succeeded is they used a downgraded GPU.
Yep.
They used the H800.
You fit somebody into a box and they'll try and innovate out of the box, right?
Yeah. If they would take the H200, which is much more powerful, that they don't have access to, or the Blackwell and the Rubin, the 100% active time that they achieved would drop to around 83% active time with H200. And if you go to Rubin, it drops to less than 20%. So you need a much more powerful scale-out NIC to allow them to shorten the time of transfer between GPUs. And when you get to 800 gig, 1.6 terabit, latency becomes much more of an issue because it consumes more time out of the transfer time.
Is that because we're also sharding the workloads differently as we scale up the networking?
Yeah. Time to first token became a very important
king, yes. And that's compute bound.
And the more agentic AI will continue, and you will have agents using LLM 50 times, 100 times for every request. Latency is king. So we're splitting the prefill between 64 GPUs today, just to shorten the time to first token. Yeah. NVIDIA even announced that they have now a new GPU.
I saw that.
Amazing. That less HBM, GDDR, because it's compute bound, the prefill. The decode is memory bound. So,
but what you're saying is, even though it's a compute bound workload, if you have to split it across many compute chips, you're still network bound at the end of the day.
Yeah, because network is becoming the connectivity.
Yeah.
It just data center scale instead of on one board.
I do wonder why NVIDIA didn't add NVLink to that chip then.
I think they are looking at it as another chip in a server that has Blackwell or Rubin with NVIDIA.
Yeah.
It's like a companion chip that will do a very efficient prefill. But still, if you want to split it between multiple of these, you will go through the
large
NVLink
context
or
or
InfiniBand, or in our case with UEC, Ultra Ethernet.
Yeah, I mean, not everybody's going to buy a NVIDIA system at the end of the day, and I think that's
not everybody can. Yeah,
and you need to be able to supply the market who either can't afford or can't wait
for that hardware, right? We're hearing that it takes 52 weeks to get an NVIDIA GPU if you
Yeah.
order one. So
And you see a lot of investment in the hyperscalers doing
Yeah.
their own XPU. Google have a very successful one in the 7th generation already. All of them need networking solutions.
yeah, so tell me what your customers are asking from you.
So in the first generation, it was mostly enterprise and neocloud CSPs that wanted to squeeze more out of smaller models. In this generation, we're working closely with the hyperscalers, and they're asking for the highest performance. If you read the announcement, it's going to be 1.6 terabit, when others are developing 800, because they just need more. They need more. They're not happy with the amount of scale-out networking they get, and latency. Latency is everything. So we took the AI NIC we had in the first generation as an embedded NIC. We boosted up to 1.6 terabit. And we really redesigned the front-end packet processing and the transport for Ultra Ethernet for the theoretical limit of latency. And we want to reach 2 microsecond end-to-end, which means 500 nanosecond for the NIC itself.
Yeah, because that only works for not only language models, but also things like recommendation engines, where every millisecond and every percentage of accuracy really matters. So describe to me, what those conversations with the customers look like, because obviously they're speaking with a lot of other companies as well, right? Not just you guys. And they go, oh, okay, so you've got this first generation chip, the NL1, this this chip that helps with data flow, but also has networking. Do they turn around and say, well, can you just make the networking part? And because I'll show up on a slide of your roadmap, because I know you've got some other stuff coming down, but.
Exactly how you described it. It's when you get them excited and interested enough, they're starting to share with you what they really need.
Yeah.
And not only how to use what you built.
Okay.
So NR1 was when it's incepted based on our data center experience. NR2 is actually what customers are asking for. A lot of it is around the balance between flexibility, like the DPU gives you.
Yep.
You can program any transport, any acceleration, but it costs you latency because you go through the CPU or other accelerators. So the balance between flexibility and low latency. So we're building multiple transport layers into the NIC. The main one, the Ultra Ethernet one, is just custom, very efficient, very low latency. Beside that, there's a flexible transport engine for extras, where you are willing to pay more latency,
right?
But you need more sophisticated, more programming, and more future-proof evolution of.
Is that things like security, or is that things like actually inline compute?
First and foremost, it's networking, just different transports like Rocky or UEC.
Right. Yep. Yeah.
And TCP sometimes.
Yeah. Okay.
And the second one is in network compute. So collective acceleration, non-math, like others had promoted, but we also took the AI hypervisor that we developed into the first generation, and we did a small version of it for the NIC. And beside that, there are DSP capabilities and custom compute. Very, very simple mathematics. When you collect the data, that you can offload some of the compute that the GPU does today.
Yep.
And the impact is not to free the GPU. The impact is to lower the amount of data that you need to bring. Because if I need to collect thousands of small tensors and compute them, it's a lot of traffic. If I can...
Especially if it's asynchronous.
First, and if I can first compute them, I reduce the amount of output, and then I transfer. So I shorten the time of transfer, and I actually, on the system level, I improve the efficiency.
So speak to me about this AI hypervisor thing, because I think I saw it last year. I was like, wait, what is that? It seems like an interesting concept.
The way most of the industry work today is that if you're using a PyTorch runtime or Python or any other VLLM, usually the sequence itself between the different steps of compute is managed, the control flow is managed by the CPU.
Yep.
The AI hypervisor allows you to understand this flow, this data flow, or the control flow that is attached to it, and offload it to a AI hypervisor. What is it? It's a set of queue management capabilities, scheduling in hardware, dispatching, and now the data movement, the programming of the different engines, whether it's the GPU, the DSP engines, the in-network computing, the NIC, are offloaded to a piece of hardware that can parallelize everything.
Okay, so being in what is effectively a hypervisor allows you to do some workload detection and management and then intercept where needed to the engines you have.
Right.
And
you natively expose it into Python with libraries, or if you're willing to invest the time, there's an offline pre-compiled flow that you can just compile your use case and create the artifact for the hypervisor to run the sequence.
So talk to me a bit about the ability to just pick up and play. Because obviously, we're here at AI Infrastructure Summit, and there's, we can see out into the hundreds of companies in front of us, and a lot of them, they all speak about performance, they all speak about latency, they all speak about uptime and tokens per second. Trying to get them to talk about ease of use with their hardware, whether they're doing compute, whether they're doing networking, or even some of the software guys, you say, how easy is it to use your software? And they go, shh. So talk to me a little bit about that.
First of all, I have to admit that in a sense, their work is much harder. The ones that are trying to do another XPU are coming from behind, and they need to compete with the amazing software stack that NVIDIA gives you. We don't have that problem. We are hosting those XPUs. So in many cases, we hide their deficiencies because we optimize the use case for the customer, and he gets a complete server experience. But in the second generation, the NR2 AI SuperNIC, the problem is even simpler, because we're not going after the complete compute problem. We're going after the networking and the in-network compute problem. It's a plug and play. You just drop in a replacement NIC. Interfaces are very clear. You need to be very efficient in transporting the data. And the in-network compute is just supporting the different CCL libraries and making sure that the library configures you, but the data path is completely offloaded to hardware.
So all those CCL libraries, these are the libraries that help all the networking talk to each other. They're all ready to go from all the different vendors. And it's because it's all UEC compliant, is it?
First of all, they can run on TCP or RoCE or InfiniBand or UEC. The underlying...
They're agnostic.
They're agnostic in the upper level. It's up to the vendor to implement the different support for the different protocols. It's an open source. A lot of people in the industry contribute to it. Our responsibility is to make sure that we're compliant with the CCL library that the specific customer had chosen. If it's with NVIDIA, then it will be their promoted CCL.
So, I mean, you showed off your roadmap at a presentation yesterday, and you're going down this chiplet route. And for anybody watching the channel, you may or may not know about my opinions on chiplets. This whole idea of an open chiplet marketplace seems, I don't think it will ever exist, because I'm seeing a lot of people build chiplets and everything's internal. So this new NR2 SuperNIC, you said this is the first chiplet of a family of chiplets. So tell me what that means to you, and from a design company, from a product company, what that enables you to do.
So I tend to agree with you. Collaboration on modular approach is hard, but it's doable in my opinion. Back in the days when
we used to say the same thing
about
IP.
In 1997, every company would develop all the IP by themselves. Today, it's a big business for Cadence and Synopsys, ARM, and others. It's just moving to modular. It will take time because everybody's saying, I'm supporting UCIe, but when you get to the details, those two UCIes developed in different companies don't connect.
You need the compliance tests and everything else,
For us, The first market we went after is actually the data center CPU market, replacing the CPU with a more advanced heterogeneous compute solution. When the market pulled us to do the scale-out NIC, we said, okay, this is another product line. This is another market segment. It's the NIC market in the data center. Are we going to do monolithic solution for each one of the product lines? And we understood that the next generation of the AI CPU that is going to be based on V3 CSS is going to need the same NIC. So first and foremost, we went modular to simplify our development flow and be able to do like a TikTok. And you can also choose different process technologies for different tiles or different chiplets. So the first chip we're going modular is the AI SuperNIC, and it's going to be a component in the second generation of the AI CPU.
Okay.
It opened another thing for us. And you see a lot of companies like Rebellion, for instance. They have implemented their compute tile, and they have an IO die.
Yes.
This IO die is the piece that scales out or scale up. So it's another business opportunity for us. A hyperscaler can integrate the AI SuperNIC, the NR2, as a die.
Okay, so you're going to be selling the dies themselves, not
we're going
just
to
the
sell
solution.
dies. We're going to sell chips, and we haven't sold chips and dies at all. We only sold systems to date.
Okay.
So it's a new thing for us. We're going to sell dies for integration in package, chips for modules like the Blackwell rack that has a 1U with CPU, ConnectX-8, 2 GPUs. So there's a ConnectX-8 there. So we're selling chips, and we're going to sell PCI cards for OCP or for chem cards. So it's gonna have a variety of solutions for the customers.
Does this mean the business has expanded? It sounds like you need another 150 people to deal with that.
Yeah, yeah, you're right. Are you looking to invest?
So what you're saying is you're going through a funding round.
Always.
It's so yeah. Describe a little bit about NeuReality. I know you guys are based in Israel. You've been 6 or 7 years old now.
We're actually almost 6. We started in 2020 when we raised the first money. We have a very good engineering site in Poland, in Krakow, which we're very happy with, and the business team is here.
Whenever somebody says to me, Ian, you track so many startups, where are the customers? What answer do you have for that?
Where are the customers?
Yeah.
Today they're a very big enterprise with their own data centers, and smaller cloud service providers that are looking to boost their longevity, I would say. They're selling metal as a service. They're fighting on margins on top of what they buy from NVIDIA. And they want to start selling more inference as a service. Access to Llama or Mistral or fine-tuned models that gives them more margins. And actually, it gives them the ability to invest in optimizing on the infrastructure level, because it opens more margins for them. The price is determined, the price of the token is determined by the market. But the more efficient you are on the infrastructure, you can take more earnings.
Do you find that, if we look at, say, for example, the Neo Cloud market, that's kind of booming right now, and they're also looking for customers as their tokens as a service. Do you find them willing to take risks given the nature of the competitive market they're in?
On the inference as a service, yes. On the common huge deals that you read, like Nebius and CoreWeave and Lambda, it has to be NVIDIA. This is why Microsoft will pay $19 billion deal for, 5 years. And it's running training and inference there. They're taking less risks.
Okay, so, but obviously from NeuReality's perspective, we're all saying that the market is growing for this, right? So even though those who don't want to take risks, there's enough people taking I wouldn't. Risks is probably a bad word. Being adventurous and examining what's available, I guess. I always want to hear more of those stories of people saying, "Oh, we actually tried your stuff and it works. Here's a check." You know.
I think that I'm very optimistic about NR2.
Yeah.
Because less people are asking, and I say people, I mean OEMs, system integrators, end customers. They're not asking what NIC do you have there. They're asking what GPU, what is the software stack. And NIC is somewhat an easier
It's almost like
sell.
a commodity.
Yeah, well, you have a lot of gross margins there because it's a high-end NIC, but in a sense, yes, it's less complex, the sales motion and the integration, and I believe that NVIDIA will continue to lead, but we're going to see more success stories like the TPU.
Yep.
A lot of money is invested there. At the end of the day, when you own the hardware, you can do all kind of optimizations, and hyperscalers will get there. And even companies, the next hyperscalers, I don't know, the OpenAIs of the world, Anthropic, and those. And I think this is the right path for the company to open this second product line and really invest in allowing all these XPUs to connect well together and achieve the best efficiency they can.
So while we're here at the AI Infra Summit, obviously I can imagine the launch of the NR2 and the SuperNIC was high priority for you.
Yeah.
What else do you get out of an event like this?
Well, we meet partners. For us, it's a key. We go to market with partners. Every system we sell today has a GPU from Qualcomm or soon from another GPU vendor, and customers. Those kind of areas bring specific customers, not all types. And for me, it's another opportunity to be in the US. So usually I do a 2-week tour.
Yep.
And I go through other customers across.
I know how you
the,
feel.
Yeah, you do. So that's that. But another announcement that we've made, and it's important today for anyone who uses our existing systems, is that we already run UEC on the NR1. And it just shows you the level of flexibility we have embedded in our AI NIC.
Yeah, I saw that was like a software update.
Yeah.
Was that by design or was that by chance?
No, it's by design, because we designed a network engine to be able to run AI over Fabric protocol, our own proprietary, Rocky V2, TCP. So boosting it to UEC, there's more we can do in customer acceleration, but we have this flexibility like a DPU to run anything. So we put that, it shows good advantage in latency. So when we do pre-fill disaggregation today with NR1 and Qualcomm, it already brings value to customers. So
it almost sounds like an FPGA.
Not FPGA, but yeah.
Firmware flexibility.
Yeah, firmware flexibility, exactly. And CCOM-based ruling and stuff like that.
So what does the next 6 months look like to you?
Hard work of bringing this NR2 to market. We're planning to have it in customers' hand the second half of next year, and make our customers happy. A lot of them are dealing with the new coming LLMs and agents that introduce new APIs. So we work hard on exposing new APIs that serve our customers. Customers that buys the NR1 inference system, they don't have to deal with an open box and do everything themselves. We do it for them, and we expose all capabilities through development APIs, deployment APIs, and serving APIs. So that's where the engineering is focused and the business team.
Sounds good. If you guys want to hear more about NeuReality, do stay tuned. I really want to get a deep dive into the NR1 and now the NR2 with what you guys are doing. But thank you, Moshe.
Thanks for having me.
And yeah, good luck with the rest of the show.
Thank you very much.
Now, I've spoken with over 100 CEOs at this point, most of whom are at the leading edge in terms of hardware, performance, efficiency, or optimization. Each one gets the same treatment. Tell me why your solution works, why it matters most, and who is going to buy it. Now, what excites me most, usually, is when a company is trying something new that the others haven't considered. We're talking things like wafer scale Cerebrus, massive networking tens torrent, or super high efficiency dataflow like Efficient. Moshe and the team at NeuReality have been on my radar actually for a number of years. Here's even a clip of me talking to him at Supercomputing about the NR1 a couple of years ago. While we're still talking about that same chip today, the value prop hasn't changed. Data going from storage to accelerator is usually not in a format easily consumed, and the CPU isn't the most efficient transformer for that data. The NR1 as a concept had my interest then as it does today, and we really need to see it deployed. Keep an eye out for NeuReality's customers, as they're still only a Series A startup at this point, but when we get a chance to deep dive into their architecture, as I know they're working with ARM and IBM, you'll hear about it on this channel.